So who is saying we should repeat? The person is just from repeating. Where is the... Okay, so I have started, we're continuing, but I'll not continue because people here, they're still saying repeat. I'm saying when I explain here, you're saying, you're telling me to repeat. So I wanted another tongue. That's why I was asking, where is this person who can help us? Our brothers, they tried. So, okay, so guys, who is going to help us with the explanation? Now a girl to help us. A girl, because I'm not sure if girls have understood. So I wanted a girl to help us to explain. The boys part, the guys are explaining. Now a girl. Changu. There's Changu here. There's Messi. Mlenga. Anyone? Mlenga. You guys. Someone to help us? Okay. So, can I use the... Excuse
Gibson
me?
can try to explain.
Gibson, I wanted a girl. A boy has already done it. So let me do it. Can I use... Maybe I should use another language. You don't understand. Maybe I'm too fast. Am I too fast? Am I too fast?
No.
Okay. So the one who asked, I sent a video in the group. The ones asking, and it's the same question. So those asking about this question, I've sent a video in the group. The same explanation. So if you've not understood, what I'll say is this: go back to the video, watch it 3 times, 4 times, 5 times. Watch the video. The explanation which I'm going to give you is the same explanation. And then I've said there are some of your friends who've understood this concept. Don't be an island. Ask. Asking doesn't mean that you don't know. Asking means that you want to know. So ask your friends. That's why you've got friends. I will not always be there, but you have your friends, the ones you sleep with, they've understood. Your friends, you have their contacts in your phone book. Text them, humble yourself, ask them. And then those who've understood, when you're asked, help out. One day you also need help. So that we shouldn't waste time, I want in this 1 hour we finish polynomials, so that on Wednesday we do TDs. You understand more when you do TDs. There are some questions, I'll prepare some questions, you try them out, and we'll come and solve them. Each question, each exercise I'll give you, we shall solve them together. Yes. So let me continue. We stopped on Theorem de Bézout. So this theorem, you need to understand it. You learn about it, Theorem de Bézout, you just need to know the equation, and you understand it more when you do the actual questions. So Theorem de Bézout, AB appartient à K, A et B sont primes entre E, si et si seulement il existe où V appartient à K, X, where A fois U plus B fois V égale A. So primes entre E. This is a very important point. You need to note this. So primes entre A, only themselves can go into each other. Only A can go into B and B can go into A. That's what it means. So primes entre A. Or in a simpler word, you can say it's only one and itself which can go into it. One and itself. One and itself which can go into it. So, calcul pratique depuis GCD. Il repose principalement sur la division euclidienne, c'est-à-dire AB appartient à KX, si B égale 0, PGCD AB, si B égale 0 est A. So if our B is equals to 0, it means our PGCD of AB is equals to A. Supposons que B is not equals to 0. If B is equals to 0, we said our PGCD will be equals to R, right? Now let us suppose that B is not equals to 0. So now we're solving normal polynomials now. This one, don't worry about it. Will not give you a B is equals to 0. Where your interest is, you need to understand this. So they're saying la division euclidienne de A par B donne, il existe strictement QR appartient à KX, KX by KX, A is equals to B fois Q plus R avec degree de R is less than degree de B. This is the same thing which we are doing there. So we are doing the division euclidian. This is our equation, right? One is stop when this is less than this. And then on a alors PGCD AB égale PGCD BR. D indivisible commune à A et B, D divise A et D divise B. We found our PGCD, which we call D. So we know that when we find the highest common factor, there's definitely a highest number which can go into both A and B. So this is what we're talking about here. D indivisible commune à A et B, et D divisé A et D divisé B. So we're going to have, now we're making equations. So we're saying A is equals to D for A, and B is equals to D for BR. These you're going to find them as you be doing the calculations. That's why I'm saying you understand this theorem more when I give you, because I've added the example, it's in the TD. So we're going to solve this question in the TD. So don't worry about this. The only thing you're supposed to know is this equation. This equation is very important. Know it by heart, and then you're going to understand. So the first thing, so this is very involving. You have to do the division Euclidean until you reach a point where you have all these values. You found your Q and your R, and where the degree the R is less than the degree the B. So we're going to have A is equals to D for A prime. You're going to find this the A prime when you do the division Euclidean. This is any polynomial. Even here, this is any polynomial. We're just denoting them by B1 and R1. And then on R, we're working with this same equation here, guys. So we want to make R the subject of the formula. So for us to make R the subject of the formula, this goes the other side. So we're going to say R is equals to R minus B for Q. What is our R? Our R is equals to this. What is our B? Our B is equals to this. We come and replace here. We replace here for this. And then our D will be outside. This is our PGCD R minus BR Q. Donc D divise R. So we have shown that D divise R by this. Alors, because we've put it in a form of what? We've put it in this form. So here we have R. So it means this can divise what? R here. The way we have this equation, this here implies that B can divise this. That's what it means. So it's the same. We have made D here. We factorize D, we have D here and R, and we've proven that don't D divise R, and this is what we're showing, that the PGCD of R B is equals to the PGCD of B or R. On resume, we resume now. R appartient à KX, B appartient à KX, et supposons degree de A is greater or equal to degree de B. Degree de A is greater or equal to degree de B. For you to divide B into this, the degree de A must be greater than the degree, it must be greater or equal. Yeah. Then we've got I is equals to BQ plus R. So this is the equation you're going to have when you do the division of this. You're going to have your Q and your R. And the degree de A is less than degree de B. PGCD the A is equals to PGCD the B the R. That's all about Theorem de Bézout. So Theorem de Bézout, the first thing, know what this equation. You are going to define your U and your V. When you do that, you are going to know what your U and your V are. So our main aim is to come up with this, and you can use this theorem you can use this equation. Maybe you want to find what your U is, what your V is, what your R is, what your B is. Usually you're given A and B, so you want to find what your U is, you already have the V using this equation. So in the TD, you understand it more. For now, I know you have a lot of questions, but in the TD, why I never added it here, I wanted you to study this part. After you study it, I'll give you the TD. You will try it according to what you've understood on the notes. But if you have problem, if you will not understand it, if you will not do it, just do what you can in the TD, which I'll give you. Don't send me the answers. Do what you can. Pack your book. After you do it, you do all the questions, you pack your book. The time we meet for the TD, for correction for TDs, open your book. As we'll be passing through, you correct yourself. What I want you guys to build on yourself is confidence. What kills people in universities, especially in Morocco, is confidence. Confidence is very vital. So for you to have confidence, start solving questions on your own. Always don't depend on your friend. Go to your friend when you've done what you can, and not every time you leave your book, you can copy from your friends. In the exam, you'll be alone. So that's why I give you this week. So that's why I want you to try out the TDs before we meet. I don't know if here there are any explanations which you want me to give you. Otherwise, this is all about Theorem de Bézout. It will be understood more when we do questions. Any questions?
Yes, question.
Yes.
On the first question,
yes.
The one having A dot is U, B dot V?
Yeah.
Yes. So what are these U and V? Are they just constants, or how can
this U and B?
Yes.
It can be a constant if your polynomial will just have a constant, because a polynomial can be defined by P can just be equals to 1 when you've got x to the power 0 to give you 1. So it can be a constant or it can be a polynomial, but what you're supposed to know is either a constant or a polynomial. And when it's a constant, it will be in a form of a polynomial. It will be 1, but it will be a polynomial because we're studying polynomials. Are we okay there?
Yes, thanks.
Yeah. Any other question before I move on to the last part, which is polynomial irreductible. Polynomial irreductible. Okay. If we're all together, we can raise our hands as I go to polynomial irreductible. Okay. Okay, thank you very much. So at least we're moving together. So now we go to polynomial irréductible. Definition: soit P appartient à Kx, soit P appartient à Kx. On dit que P est irréductible si les seuls divisés de P sont alpha et alpha P avec alpha appartient à K. We've got this set one is equals to 0. We've got a proposition here, Theorem de D'Alembert. You're going to understand it more here. Theorem de Lambert. This is the proposition of Theorem de D'Alembert. Les polynômes irréductibles dans C sont les polynômes de degré 1. A polynomial won't be reduced to its final form when it has a degree of 1. in C. This is very important in C, because you'll be taught to decompose a polynomial. You'll be taught to reduce a polynomial. It's only considered to be a reduced polynomial in its simpler form when it has a degree of 1 in C. And then le polynôme irréductible de A. So le polynôme de degré A et le de degré D avec des discriminants strictement négatifs. When it's to the degree 2, its discriminant must be negative. When it's in C, in real numbers. This is very vital. When you go back here, this is this polynomial is reduced, right? In R, because R I said is 1 and 2, right? Is this polynomial reduced in R? Are we there? Is this polynomial reduced?
It is.
Yeah, so because the degree here is equals to what? 1. It's both reduced in C and in R, because in C, in complex numbers, we said it's only 1 with a degree of 1, and then in R it's 1 and 2. Keep that by heart because you use it. So theorem.
Then before you proceed,
Yes.
how do you define the discriminant of it?
Do you know what a discriminant is? Before I define it.
Not really.
Someone to help us. Those who did this is you know it. It's just that.
Can I try?
Yeah. Yes. You can go ahead.
Square root of b squared minus 4ac.
Yeah, that's it. That's the equation. Just use that same equation and just solve its discriminant. Then when it's discriminant, before you go to the final answer, you first solve its discriminant, and if its discriminant is equals to a negative number, then that is then it has been reduced. Are we okay?
Sorry, I didn't get it.
The one who explained. What did you say? You can.
Square root of b squared minus 4ac.
What is
yes. Square root of b squared minus 4ac. You understand? You know where the AC, where they come from, the B.
Oh, it's the same discriminant when the what? In the quadratic equation.
Yeah, the same. That's why I said you know it. It's just that the way it has appeared here, you know it. You know how to use it. We are fine now.
Yeah, we are fine.
Okay. Thank you very much. So, pour tout polynôme P dans C s'écrit sous la forme d'irréductible. So, pour tout polynôme P dans C s'écrit sous la forme D, which is said as irreductible when we have one. This is the polynôme X. When you've got this, AEX A1 to the power 1, we're going appartient à nombre naturel net3, meaning apart from 0, AI est distinct. So for C, we said it only be reductible when your what is equals to 1 here. It only be here it may have n, not here. Here it may have n, it may have 5, 6. That's why we're putting it in this form. But inside here, this x must be to the 1 to the power 1, degree 1, degree 1. That's why I put it degree 1. That's all. Then it's reduced. Or if it's not equals to degree 1, then it's just its degree is equals to 0. Just the same, just have a constant by that time. When this degree is just equals to 0, you have a constant. Yeah. Then for 2, put 2 polynomials dans A. S'écrit sous la forme d'irréductible. Px is equals to AI x moins AI. Power here, you have any power, but inside here you have, this is to the degree 1. And we said for R, I see that degree 1 or degree 2. So the one for degree 2 to be written in this form, x squared plus b1x plus a constant. This is how you write it in. Then here you've got whatever powers you're going to have up to power m outside, but inside it will be up to square 2. So this is the representation of it. When you do the TDs, you see the actual question. So the one who was talking about the discriminant is this. You mean when you do b squared minus 4ci is less than 0, is on a negative part. Then AE, BE, CE appartient à alpha E, BE appartient à nombre real, nettoie, AI est distinct. That's all about irreducible. Is just a simpler form. Just it's all about you reducing a polynomial. And you have to know that a polynomial is reduced when in C when it has a degree of 1, and in R when it has a degree of 1 and 2. You understand? If that's why I say it's very important for you to do complex numbers, because complex numbers, because when you have one which is in degree 2 and they tell you you finish it, or you need to decompose it in C, you have to know the identities, because this maybe to have an identity of it. Maybe here you've got x squared. Here we have x squared plus x plus 1. The identity of this is equals to what? You have those identities in the what? It's equals to x minus j bar. You start using up my j bar, j whatever. That's why I said the identities are very important. You need to keep them par cœur, by heart, because you have to use them when reducing a polynomial. In C, they tell you in C, and you've got an identity of 1 which is in R. Just get this identity, put it there, and then you've decomposed it. So it's all about you knowing the identities. Go back to number complex, very important, and go and you study this school again. Yeah, otherwise, last part was just looking at the notion of the PPCM, which is plus petit commun multiple, which is AB appartient à KX, KDX. PPCM is AB. This usually they don't ask you to find the PPCM, unless some universities, but it's rare. Just concentrate on the PGCD. I just indicated this so that you know that there's also PPCM. In case your professors tell you to find that, they'll teach you how to find it. Yeah, but I thought of, in case you meet it somewhere, you get confused. What's PPCM? So it's plus petit commun multiple. So just finding the multiple here, not finding the factor, finding the multiple. So up jusqu'à maintenant, ça va? Ça marche?
Oui, ça va.
Okay, d'accord.
Trying to repeat the last part.
Which part? The last part, bosses. The whole thing, the polynomial. So I start from the proposition. Which part, bosses?
Polynomial irrational.
Okay. Polynomial irréductible. So we said soit P appartient à Kx, on dit que P est irréductible si les seuls divisés de P sont alpha et alpha fois P avec alpha appartient à K. So our alpha appartains, the alpha here is this alpha here. This is where with its alpha. So this is the alpha here. And then we are saying proposition theorem de D'Alembert. Le polynôme irréductible dans C sur le polynôme de degree 1. So a polynomial is only reduced in C when it has a degree 1. A polynomial is only reduced in R when it has a degree of 1 and 2. Keep it by heart, par cœur. When when your friend asks you about, if they ask you in C, you can only consider a polynomial to be reduced in C when it has a degree of what? You don't need to hesitate, it's when it has a degree of 1. Where in R, it's when it has a degree of 1 and 2. That's very important. And then you go to the theorem. Then you go to the theorem. Pour tout polynôme P dans C s'écrit sous la forme d'irréductible. Px, this is the formula of it. That's how your polynomial irreductible will look like, with x to the power 1 here, inside part, but here you can have any powers. And then you go to the one in R. You've got two parts. You've got the one which is to the power 1. Since you say this 1 and 2, and the one which is to the degree 2. So this is how you're going to have their polynomials in representation. They'll be like this. That's what these diagrams are all about. And then here, just looking at it, how to, for this x squared, how to prove it. It's just this x squared, b squared minus 4c. We are supposed to have r. Anyway, our r here is equals to, our I here is equals to 1. That's why we just put 1 here. Then our b we don't know, and our c we don't know. So that's why here our r is equals to 1, is less than 0. So r, e, b, e, c, e appartient à r. Then we got this. Yeah, we've got lambda e, b, e appartient à nombre naturel. A, e est distinct, notion de ppcm. Plus petit commun multiple, ppcm. This, I just wanted to give you this. Yeah, so that you can know the notion of the ppcm and what ppcm stands for. Otherwise, I have no questions on that. It's just a general knowledge which you just have to know. Yeah, so that's all about polynomials. This is the end of polynomials. I can call it a wonderful lesson. We shall see if we've understood in the questions. There are some of us who understand faster. There are some of us who don't get the concept there. And then there's how God has created us. So don't think it's hard, or you see your friends understanding, you can't understand, you have some problem in understanding. That's how you are, but you can improve, you can help yourself to understand more better. If you've got a problem in understanding, make sure you pass through a lot of questions, you do whatever, and ask God to help you to understand. Ask God. Or things which are impossible with men, they are possible with God. So others understanding is not by luck, but they've involved God in their life. So that's what I can just tell you. Mathematics is all about doing, and doing. And mathematics is not about packing your work and putting it aside. Otherwise, next week we are starting fractional rationnel. That's what we'll be doing. I like the progress, but I don't like the progress of where I like the progress that we've finished, but I don't like the progress that you've not understood. So I want us to move together. So if you will not understand by the time I give you the TDs on which day is this? On Wednesday. If possible, we'll do it again. But I know you've understood. I know that, and I'm sure soon you'll be having your lessons. I may give you 10 minutes of rest. Yeah, 10 minutes of rest so that you prepare for the next lesson. Yeah, I have recorded. So those who want to watch the videos, you can check them out. Yeah, you can check them out. And then I don't know who is this one who is writing this comment. Who is Musepeda? Musepeda. Yeah, so let us just do our work. And then Musepeda, I hope you've understood. I hope you've understood. We are here for serious business. So jokes aside, guys. Yeah, so that's what I just had for you guys today. So I wish you all the best. Those who not handed in the work, please try to do that work which I've given you. Yeah, try to do it. Ask friends where you have problems with friends, they cannot explain, you know, my DM. Feel free. Feel free. I'm not here to perform. I always say this. I don't perform, I teach. I'm not a performer. A performer will just show you things on the screen and then it will make you wonder and then you go back and you'll be wondering how he did that. I'm here to teach. So if I'm here to teach, where there are questions, you ask questions. When I give you work, you do it. Then we move together. Yeah. So are we okay? I can end now.
We are okay.
Okay, okay. Otherwise, have a blessed afternoon and have a blessed lesson, the next lesson. Yeah.